Hello everybody, welcome back to another video, and in this video we'll be deriving the complex definitions for the sine and the cosine, and then from there you will be able to get any other trig function that you desire. So of course this all comes from Euler's identity, which states that e to the I theta is equal to the cosine of theta plus I sine theta, and I'll be definitely doing a derivation or proof of this in one of my future videos. But where do we go from here? How do we isolate to solve for sine and cosine in terms of these exponential functions? Well, what we can do in something that's and something that will be quite helpful is to recognize that the trigonometric functions have properties when you take the negative angle, and some of them will allow you to simplify things to have something that is not entirely different from the original expression. So what we can do is we can try plugging in negative theta into our theta here. And of course, that'll result in e to the negative I theta. That's equal to, and then we have to accordingly put the negative theta on the side of the trig function. So we know that cosine is an odd function, so therefore cosine of negative theta is just cosine of theta. That stays the same. However, the sine is an even function, so there's symmetry about the y-axis. So therefore, if we have the sine of negative theta, that is going to be the negative sine of theta. So this positive gets changed to a negative I sine theta. So what we can do here is we can treat this like two systems of equations, but in this case we're just trying to rearrange or solve for some variable, which in our case is sine. So we can add these two together. So what we'll do is we'll take the positive root, and taking the not the positive root, taking the addition of these two identities, and if we add them, we see that we get e to the I theta plus e to the negative I theta. And then on the right hand side, we'll see that adding a sine to a negative sign will just cancel out, and it'll be a result just left with 2 positive cosine of theta. And then therefore we can see that cosine of theta is just going to be dividing by 2 on both sides, e to the I theta plus e to the minus I theta all over 2. So this is the first thing that we have. Now secondly, we can subtract these two equations. We can take the subtraction of these two, and we see that e to the I theta minus e to the minus I theta is going to be equal to, and then cosine, positive cosine, subtracting from positive cosine will cancel out, and a negative I sine theta will result in 2I sine theta. And of course, rearranging to solve for sine theta, so that is dividing by 2I, we'll see that sine theta is going to be just e to the I theta minus e to the minus I theta all over 2I. So what we'll be using here, this is essentially it. And what we'll be doing in today's video is just finding out what the tangent will be. And from there, you can really get everything you want, because then you could get the cotangent, and the others are just reciprocals of each other. So know the tangent of theta is equal to the sine of theta over the cosine of theta. So let's just work that out here. So the first thing we'll see is we can actually write this in another color so it's easier to see. So we'll take here, we'll say this will be sine of theta, and we're dividing all of that by the cosine of theta. So let's do that here. So that's going to all be equal to, and then we have the sine of theta, which is e to the I theta minus e to the minus I theta all over 2I. And then that's being divided by the cosine, which is going to be e to the I theta plus e to the minus I theta all over 2. And what we see here is we are dividing two fractions. So what we do is we take this times this divided by this times this, because it's just in the form of a divided by b divided by b divided by c, and you get 80 over bc. So here you'll see that we get the 2 being multiplied by the quantity from by this quantity here from the sine, complex sine. So e to the I theta minus e to the minus I theta, and that is all going to be divided by the quantity from the denominator from the complex sine, which is 2I, and that's all being multiplied by this, which is e to the I theta plus e to the minus I theta. So what we'll see here is that this this 2 and this 2 will cancel. However, we still have an I on the denominator, so what we'll have is we'll just have e to the I theta minus e to the minus I theta, and that's all over. And then we have the I, which is here, and then multiplied by this. So how do we simplify from here? Well, there's not much simplification you can do, but one thing that you can do to make it easier to work with is to multiply by I on the numerator and the denominator. And that is because we know that I squared is -1, because by definition I is the square root of -1. So therefore I squared will be -1, and multiplying by I over I, we'll see that this I multiplied with this I will become a negative, just a -1. And we'll see that here will produce negative I'll just write it in one color now, e to the I theta minus e to the minus I theta all over, and then this I is gone now, and we just have e to the I theta plus e to the minus I theta. And here, just to finally clean this up, we can distribute this negative to each term in this bracket, and we'll see that we finally get I times e to the negative I theta plus or minus e to the minus I theta, or e to the positive I theta, and that's being divided by this same expression that we have here. So this is what the complex tangent is. And the way that we can also we can continue to do some more factoring. We can factor out e to the I theta, and then we'll get e to the negative I2 theta, but this should just be good for now. And one question that we'll be looking at using this is something is a very interesting question, and that is looking at the sine of I. So how do we do this? Well, we'll just use our complex definition of sine. So we know that sine is this right here. So let's just plug in our theta, because our I is actually our angle in radians. So we'll plug in that as our theta into our complex sine formula here. So it goes here that sine of I will just be the same as e to the I times theta, which is I, minus e to the minus I times theta, which is I, all over 2I. And we can use the same property here, that I squared is -1. So we see that sine of I comes to be e to the negative, I squared is -1, so e to the -1 minus e to the, and then negative I times I will be negative of -1, which is just 1, all over 2i, like so. And what we can actually do now is we can, let's see what's happening here. We can multiply by I on the numerator and the denominator, and it's similar to what we did with the tangent to get this form here. We see that now sine of I is going to be equal to, and then we have this I squared is -1, so we have a negative, and then the I times e to the -1 minus e to the 1, e to the first power all over 2. We can distribute this negative to each term, and we finally see that sine of I is equal to e to the first power, I'm keeping that first power for a reason, minus e to the -1, and then all over 2. And that's, of course, with an I factored out of everything here. And does this part look familiar to you? Well, if it does, you are right, because this is actually the definition for the sine h, or sine, or the hyperbolic sine function. And I'll make a note here that sine h, which is the hyperbolic sine function of x, is e to the x minus e to the minus x over 2. And guess what? That is exactly what we have here, but with x is equal to 1. So what we see here is that our x must be equal to 1, and therefore this entire expression evaluates to the sine h, or the sine, or the hyperbolic sine of 1. So now we see that the sine of I, and remember we still have this I factored out here, that is just I times the hyperbolic sine of 1. And that is what we have here. And of course, you can create a general formula where if you have some sine of some complex number bi, let's just call it, then what you'll have is you will just have that to be I times the sine h, or hyperbolic sine, of that b, because you will follow all of the same steps, and you'll see that you'll just have, instead of a 1, you'll have e to the b minus e to the minus b all over 2, of course with that I there. So that was it for today's video, where we looked at our first, where we delved first into the complex definition of sine and cosine, and then looked at some more interesting things. So thank you for watching.